tutorial, you will learn how to assemble, program, and calibrate the Park Ranger electronics unit. For this tutorial, you will need an Amani 64 CPLD shield, an Arduino, an FM transmitter module, one ultrasonic transducer, and two op-amp modules to amplify return echoes. A traditional ultrasonic ranging module can be used in this project. However, the Amani 64 is used instead to tailor the design to our exact needs. Based on programmable logic, the Amani 64 is a rapid prototyping tool that can replace a drawer full of integrated circuits and parts. The Amani can be used for a myriad of functions such as glue logic, bus decoding, memory expansion, timing, range finding, VGA display. The possibilities are only limited by the imagination. The Amani 64 is the ideal prototyping tool where customized applications are required with a minimal parts list. The Arduino begins the detection process by sending a start pulse to the Amani 64. A 40 kHz waveform generator in the CPLD is gated, resulting in an ultrasonic pulse that is sent to the transducer. Two gain stages amplify ultrasound detected by the transducer. Because the transmit pulse is passed as well, a blanking circuit is used to remove the transmit energy, allowing the receiver to trigger on the first received echo. The Amani then sends a square wave back to the Arduino, its length indicative of distance to the target. The Arduino converts this distance to a tone repetition frequency, which makes its way back to the Amani 64. This tone-enabled signal triggers another waveform generator, whose 200 Hz audible tone is output to the FM transmitter and into your radio. We'll begin by assembling the analog section. We will begin prototyping on a solderless breadboard. The user is encouraged to build their own custom shield if deploying this unit. For this stage, you'll need the FM transmitter module, the ultrasonic transducer, and the two op-amp gain stages. Find the analog section schematic at amani64.com/park. Assemble the analog circuit and interface it to the Amani 64. You will also need support resistors, capacitors, as well as ferruled prototyping wire. Upon assembly, we are ready to test it with the digital back-end. Stack the Amani 64 onto the Arduino. To program the Amani, an Altera-compatible JTAG in-system programmer is needed. First, plug the JTAG programmer ribbon cable into the 10-lead header on the Amani. Plug a USB cable into the Arduino. Both units will be powered by the USB port as long as the power jumper is set to the J2 setting. The Amani programming files can be found at either modulesurf.net or amani64.com. Find the radio_ping block symbol file. Save it to the root of your project directory. If you are unfamiliar with Quartus 2, refer to the Quartus tutorials found at amani64.com. Unzip the radio_ping file to your root project directory. The .pof file has been included in the archive. We will proceed directly to the programmer stage. Synthesis will be covered in another tutorial. Open the Quartus 2 programmer. Ensure that your JTAG programmer is plugged in and that your Amani 64 is powered. If your JTAG programmer is not present, go to the hardware setup and ensure that the USB blaster is the currently selected hardware. If this option is not available, you will need to troubleshoot your programmer. You can check the programmer integrity by deleting the POF file from the programming queue and click the Auto Detect button. The programmer should recognize the Amani's EPM3064 CPLD. Delete the device from the main window and reload the Amani_park_ranger.pof file. Check the Program Configure box and click the Start button. You can monitor programming via the progress indicator in the upper right, as well as the LEDs of your JTAG programmer, depending on your model. Finally, you are now ready to load the Arduino sketch Radio Ping, found at amani64.com. Once programmed, bring up the serial monitor to view diagnostics. The Arduino begins with a series of FM transmitter module initializations, followed by a series of range counts. The counts visible in this example are the range counts from my desk to the ceiling. Most likely your unit is not yet calibrated, and you'll either have the max count of 1500 or a minimum count. Begin the calibration process by tuning your gain stages to the minimum gain setting. You will see the maximum range of 1500 scrolling through. Slowly increase the gain until you achieve a consistent detection of your ceiling, if within 10 feet. Too much gain causes the amplifier to ring, and the Yamane will default to the minimum range setting, seen here in single digits. Back the gain out and try again. If you are familiar with ranging systems and the technology used here, you may play with the firmware variables such as range bias and receive blanking time to improve the performance of your system. These concepts will be covered in later tutorials. You may now test your calibrated system over the radio. Tune your radio to 97.3 MHz. Your ceiling should be represented by a repeated tone, the repetition frequency representing the range. Move your hand between the ceiling and the transducer to observe changes in the repetition frequency. Minimum range is indicated by a solid tone. If no tone is heard, the maximum range state is active. If deploying your unit, I advise building a prototype shield for the analog section, the layout of which is up to the user. I encourage you to also experiment with your own customized gain stages, complete with an adjustable threshold detection stage to increase receiver sensitivity. You may also want to boost the transmit pulse to increase range. In part 2, you will learn how to build the LED and transducer panels seen here. You can perform calibrations and tests using the LEDs as well. Follow the LED and transducer pinouts as prescribed by the Arduino sketch and the CPLD pin file.
Now this is an analog dial, and unfortunately 97.3 is populated, so I'll have to set mine up later, but you have to plug it into the actual barrel jack connector of the Arduino. So here we're about 12 feet from the transducer, and we're already getting returns. So we'll just go ahead and start approaching.